Hi, everyone. Thank you for joining me. My name is Artem Bilan. I work for Pivotal more than 4 years. I am co-contributor to Spring Integration and other projects based on messaging like Spring MQP, Kafka, and Spring Cloud Stream. Natively, I am from Ukraine and joined its Spring team after several years of hard contribution to Spring Integration because I needed Spring Integration a lot in my previous job. This is some legal note of my employer. And before I go, some remark. I have 60 minutes talk, so no reason to go away after 30 minutes. So, well, when we talk about Spring Integration, it's exactly implementation of enterprise integration patterns and messaging. It does nothing about integration with GSF or Hibernate. That's exactly messaging and everything related to integration patterns. So all those smart words like aggregator, splitter, scatter gather, routing sleep, it's exactly about Spring integration and implementations of integration patterns. The base idea behind Spring integration is loosely decoupling between components through message channels and communication between components using messages. So producers produce messages, send them to the channel, and on another side, consumer just receive messages from channel. This, we need to keep this model in mind when we develop any application based on Spring integration, and also we keep this model in mind when we develop something inside Spring integration, especially when we come to DSL. We connect components with channels. And in most cases, we may even not have channels, like this sample of XML DSL about chain. We connect components, but channels are between them as explicit. Java DSL was around several years already, but in this new version of Spring Integration 5.0, we merged that project directly into core, and we don't need anymore any external dependency. Let's see this sample in work. So the idea behind Java DSL to produce some artificial bin, call it integration flow. This is logical component which connects integration components together and expose them as bins into application context. This simple sample is classical splitter transformer aggregator. We receive some string, comma delimiter string. We split it, transform each token to uppercase, aggregate, and output it. Simple test case on the matter will demonstrate us how does it work. We use standard Spring Framework test components and send message into input channel and expect some aggregated result as output. okay, test works well. But at the same time, if you see in between components, we don't have anything. And that is done directly on one thread. But when we come to integration, we maybe would like to do some work in parallel. For example, when we split, we get several messages from one after splitting by delimiter. So to make it parallel, we easily can add channel in between, and for example, executor channel will distribute splitted messages to each thread, and they will be processed downstream by transformer and aggregator on their own threads. But when we do in parallel, there is no guarantee that we will have them in the same order. When we run the test, we will see that it really doesn't expect what we would like. So you see, order is wrong. For this purpose, we pretty easy can use a sequence component. And as you see, ADI help us to complete code on the fly very quickly. So development of Spring integration Java DSL in ADE is pretty easy. Also, we have new components like for logging, for example. And we can see each message in the logs. After processing. Sequence number is correct, so our test pass. That's one of new components in Spring Integration 5.0. The next big part of changes which we made in Spring Integration is exactly about reactive streams. Everything around our world becomes reactive, so that's not surprise that we need to do something in Spring Integration. Reactive streams idea is about publisher and subscriber and consuming events from the source on demand. So subscriber subscribe to publisher and request how much he would like to get, and then publisher starts to publish to subscriber events. More information about Project Reactor and Reactive Streams you can hear from Stefan and Simon in their amazing talk about Reactor. But at the same time, this reminds us something. Similar model, like publisher and subscriber, we have exactly in Spring Integration. So that wasn't too hard to bring Reactive Streams model into Spring Integration components. And for you, like target developers, everything still is transparent. We do hard work inside framework and make publisher and subscriber, reactive publisher and subscriber as core components of Spring Integration. We do to make it reactive, there is just need to place Flux message channel in between and use Reactive Streams consumer on another side, and all message handlers in core message handlers in Spring Integration implement Reactive Streams subscriber directly, so they can consume events reactively. We will see that in action a bit shortly. One more aspect of Spring Integration, not only like messaging between consumer and producer and message channel, but also channel adapters to some target systems. Spring Integration has a lot of channel adapters, and in Spring Integration 5.0, we introduced a new set of channel adapters for Spring WebFlux, and they are fully reactive because WebFlux is about reactive communication over HTTP. Artem Bilan will tell you more in his talk in details about Spring WebFlux. I will show you what we did for WebFlux in Spring Integration. That is pretty simple application, very straightforward. And here I built small, simple integration flow, which uses WebFlux namespace and provide inbound gateway. Spring Integration convert this inbound gateway to WebFlux endpoint, and everything rest is hard work is done by auto configuration from Spring Boot for WebFlux. This simple sample shows us how it is easy to implement server-side event pushing to client. So WebFlux inbound gateway expose endpoint and produces text event stream. That's exactly server-side event model. And as a result of this integration flow, I produce simple flux of several tokens. The result of this handle method is sent to reply channel in the headers, which is produced by inbound gateway. The test case is a bit complicated, but it's still straightforward. It's Spring Boot based test case with reactive type application, and we use here web test client to perform get URL for our server-side event endpoint based on Spring Integration. We get Flux, and then we use step verifier from Reactor test project to be sure that we consume, that everything works properly. So here we see some logs from Project Reactor, how we subscribe and consume and then complete the flux produced by integration flow, which expose the WebFlux inbound gateway. So, as I say, Artem Bilan will tell you more how it works from Spring perspective. Another aspect of new features in Java DSL in Spring Integration is about exactly consuming reactive stream, for example, Flux, existing Flux, and build it as integration flow. In this sample, I would like to demonstrate you a new project, Reactor Kafka, and how we can use it from Spring integration perspective. Also, I here use Spring Kafka, and Gary Russell will tell you more this evening exactly about Spring Kafka, how it works. So my idea here to demonstrate you Reactor Kafka in the action. This is pretty complicated test, but it's still straightforward. So it's again based on Spring Boot auto configuration, and Spring Kafka is included into Spring Boot. It has its own auto configuration there. But at the same time, we don't have embedded Kafka support in Spring Boot, so I place a note for myself for the future improvements. Kafka embedded is from Spring Kafka project. Kafka template is auto-configured by Spring Boot. Kafka properties is from Spring Boot as well. We need it later. Integration flow context, it's new component provided by Spring Integration Java DSL for runtime flow registration. So we sometimes we don't need to have statically defined integration flow and would like to do that on the fly in the code. That's an idea of what I will show you in this sample. In before class, I tried to mock Spring Boot with generated randomly selected port from embedded Kafka, which we start. I send using Spring Kafka template, send several messages to topic. Topic is configured in application properties, but that's more like matter of Spring Kafka. And then I come to already Reactor Kafka project and use special components from there to create a native Kafka consumer based on Spring Boot auto-configuration properties. So we subscribe to our test topic, then we create Flux of Flux to receive and auto-commit offset into Kafka. This Flux of Flux, just like this, because the root Flux is exactly about stream to consume it on demand. Internal Flux contains a bunch of records which we get on each pull, because Kafka consumer is pullable. So we do pull, we get some set of records, consumer records, and Reactor Kafka project wraps it into Flux. But since we talk about integration, of course, everything should be messaged. So I do simple wrapping of, actually it is going to be event of root Flux, so Flux of consumer records is wrapped to message, and then a new stuff from Java DSL, which is from publisher. So this publisher is Reactive Streams publisher. Since Flux implements it, so we can use it. And afterwards, we do some Spring integration flow. Split is based on message splitter, and in Spring Integration 5.0, we improved it to split flux. So before we got list, array, or comma delimited, but right now we can split Java 8 stream or any publisher. That message channels flux is something new in Spring Integration 5.0 as well. It is a new message channel which is publisher for reactive consumer on another side, and from one side it is subscriber to upstream publisher. So splitter will split flux of messages, and we will send them to flux message channel for reactive flow from beginning to the end. In the end of this flow, I just will send to some testing channel, which defined here as message queue based on JDBC message channel store. That just for demonstration. Why do we need Spring Integration here, right? Because actually something wrong. That's not me. Do you still see? Okay. Integration flow context, a new component in Spring Integration. Oh, okay, it's much better. Thank you. So come back, please, here. As you see, we declared integration flow on the fly without any bin definition. And then we register it into integration flow context on the fly and can use it as before. So if you have some logic, some dynamic routing logic, you can declare several integration flows on demand and registers them into application context. Actually, it is registered in the application context. And in the end, when we don't need this dynamic integration flow, we just can destroy it. OK, since it is test case per se, let's just run and see it in action. So logs show us how we get our data from Kafka Reactive Valley. Okay. The next new stuff we have in Spring Integration 5.0 is about testing. I'm sure you all familiar with all of these existing tools about testing, and we use them as well, developing our components or anything else. My colleagues from Spring Boot team will tell you more about testing support in Spring Boot. But we talk here about Spring Integration. So anyway, even all this set of components exist, we still have something for integration testing. Because sometimes we may just not have internet connection, database, or the same Kafka, or like me, I don't have MongoDB on my computer, or some other target system. So we need to mock it somehow, or stop, or replace something with something what can test our flow. I borrowed some ideas about testing framework in Spring integration from Gregory Hope and his paper about testing-driven model for integration, enterprise integration applications. I'm pretty sure that these words like generator, verifier, and stub are known for everyone, for example, from Makita framework. And, well, actually, we did nothing outstanding, just reused existing tools, but anyway, exposed some features for testing. And if we'll see examples, so this is example of some kind of real application. Idea of this application to consume messages from MQTT topics, a couple topics. I consume from a couple topics. I don't have MQTT server on my laptop. Then we route messages based on MQTT received topic and distribute events or messages to their respective channels and try to store them to different MongoDB servers to their particular collections. This sample, as you see, is based on integration flow and Java DSL, but it's exactly the model, annotation-based model, which we have in Spring integration, and it's another sample how we can define integration solution using annotations, just annotations and plain classes, not DSL builders or something else. Okay, since I don't have anything real, I try to mock everything. And the test case, that's especially what we need to do. We introduced a new annotation, which just to be clear, call it Spring integration test. This annotation registers several beans. One of them is mock integration context to interact with application context through some specific API. We'll see it later. And since we don't have real connection, we maybe would like to do not connect. So that's how we expose option not auto startup for particular bean. And in this case, when we run our application from the test, we don't connect to MQTT server. But since we don't have MQTT server and our message-driven channel adapter are not going to work, we need to replace it somehow. The idea of this test just to check that our routing logic works properly. So we need generator for some test data. We can do that with new mock integration factory and create mock message source. This factory produces message source, which is Makita mock, and it answers us some predefined messages. That's exactly our test data. So it's simple messages with simple content and special received topic, MQTT header received topic, which we use for routing logic. And if you know Mockito mock with answers may produce several answers, but in the end, the last one, it always produces the last one when all previous are already used. That's generator, our generator of data. On another side, we need to verify. For example, I don't have MongoDB, so I would like to get routed messages and verify that my routing logic works well. So for this purpose, we introduced mock message handler from the same mock integration factory. It has fluent API like handle next with consumer signature, and there we can use standard assertions to verify data. And at the same time, this mock message handler can be as a stub, like on that slide. For this purpose, we have that mentioned mock integration context and use its API to replace real bin for our mock. So this what we do with substitute message handler for. This is for, not yet, is for bin name, for endpoint bin name. That's yes, that's ugly bin name, but that's exactly what service activator annotation does in the framework. After substitution, we are ready to send messages and verify that our routing logic works well. But since we have two MongoDB message handlers, so we need to replace both of them and verify both type of messages. So that's how we have the second one, mock message handler. We do the same, and there are several sends too. So if we run this test, we should see some system out from verifications. So how to be sure that it really works well? We just need to, I guess, something like replace comment out some piece of code. And since we don't have verificator for the first message, so we get a failure. That's how new features in Spring Integration testing framework works. And the last feature I would like to share with you, we have in latest Spring Iteration, is about, I would say, backward integration with Spring Cloud Function. Spring Cloud Function is a new project, and Mark Fisher will tell you more about it and what belongs to it. The idea of this project to expose simple function, Java util function primitives as bins and wrap them to desired adapter for target serverless providers, or just expose as a REST or task or stream. That is done just choosing some specific dependency for our project. But in the project, we still develop just function, and we concentrate only on business logic in this function. My idea in Spring Integration just to expose integration flow as a function. And sample for this is very, very simple. So as you see, integration flows factory may accept just function, and then we are free to do all other our logic as integration flow chain. The function interface in this case is wrapped by Spring integration into gateway proxy factory, and that is messaging gateway. And when we call this function, it through the proxy will send message to downstream message channel for further integration flow logic. The sample can be tested with this. Yeah, I use REST adapter for Spring Cloud function, and in test case, I just perform HTTP GET method through test REST template from Spring Boot. I send some JSON as an array and expect result as uppercase transformation. Spring Cloud Stream in REST adapter it's pretty smart and understands that I provide for him array, and it is wrapped to Reactor Flux. And on the integration side, I already receive one event from the Flux. Not the whole array, but just one event. That's what we see by logs. And as you see, right, these headers we have, that's exactly what is done. This is error channel and reply channel. It's a matter of gateway, proxy gateway. But at the same time, if we come back to the sample, as you see, I have here a custom interface which, extends function, and the generic arguments are message. So this custom function I can insert here, and when we run test again, we will see some extra headers, just because Spring Cloud function is very smart, and it understands my generic types and wrap each event of the Flux into the message. And this can be confirmed with extra headers from HTTP. They are generated by REST adapter and inserted into each message. And since gateway proxy factory understands these messages, and it just does nothing and receives them and send to downstream integration flow as is. That's what we have so far in Spring integration. Okay, that's all. More information about these features and more improvements we have done in Spring Integration 5.0 you can find in reference manual. Samples application are good source for studying what we have. And you can find source code. This source code I demonstrated on my GitHub account. That's it. Any questions?